In this video, I will review the problems that were presented as examples in the reading summary so that you can check your work. Example 1, you were given several solids to find both the surface area and the volumes of. So in the first one, you were given a 5 by 5 by 5 cube. Now, as far as surface area goes, in the cube, I have basically each one of these faces, which are 5 by 5, and I have 6 of them. So to find the surface area, I would do the area of this one square, which would be 5 squared, and multiply that by 6. And as a result, I would get 150 square yards. As far as the volume goes, the formula that you're given is length times width times height, which are all the same, or you could look at it as being a cube and just do s cubed. I did 5 times 5 times 5, which is 125 cubic yards. In the next one you were given in this example, you had a cylinder. It has a 6-inch radius, and that's the base, and a 24-inch height. Using the formula of surface area equaling 2 pi r squared plus 2 pi r times h, all I'm going to do is put the two values in. I mean, this is r, this is the height. So 2 pi times 6 squared plus 2 pi times 6 times 24 gives me 72 pi plus 288 pi, which gives me 360 pi, and that's in square inches. And since the pi is already down here in the answer, I'm just going to put in the 360 in there. For the volume is given by pi r squared times h. So again, I'm just going to insert the 6 and 24 where they're needed. So pi times 6 squared times 24, which comes out to be 864 pi, and that's going to be in cubic inches. Again, since the pi is already down here as part of the answer, I'm just going to put in the 864. For the next one, you were given example 1. You're now given a cone, which is a 10-foot diameter and a 24-foot height. Knowing that that's the diameter also lets me realize that the radius would be 5 feet, because the formulas that you're given deal with radius, not diameter. Make sure that you make that conversion really quickly. You don't necessarily have to write out what the radius is, but keep in mind that it is the radius that you're looking for. So to do the surface area, I'm going to do pi r squared plus pi r times the square root of r squared plus h squared. Certainly a more complicated formula you might see in some geometry courses, but they're not going over all the structures that a geometry course would normally talk about, namely for a cone and eventually a pyramid, slant height. So they're giving you this formula which basically kind of calculates the slant height as part of this, and just say, okay, this is the formula you follow. So I'm just going to put 5 in for all the r's, 24 for the h, and I work it out. So I end up with 25 pi plus 5 pi times the square root of 601. Unfortunately, the square root of 601 is not a perfect square. It doesn't come out to be it's a really irrational number, which is why you're asked to round to 2 decimal places. And if I work that out, I get about 463.63, and that is in square feet. As far as the volume goes, the volume of a cone is 1/3 pi times r squared times h. So again, I'm going to put in 5 for r, 24 for h, and work this out. That gives me 200 pi cubic feet, and 200 pi is approximately equal to 628.32. So it's 628.32 cubic feet. And the last shape you were given in example 1 was a sphere with a 9-centimeter diameter. You can see it's going from this distance to this distance here. So again, the formulas for a sphere involve radius, so it's important to know that that is the diameter, which means that the radius would be 4.5 centimeters as a result. So the surface area, I would do 4 pi times 4.5 squared, which gives me 81 pi. That's going to be square centimeters, since the pi is already in this, because I want you to leave it in terms of pi. You have 81. It's not unfamiliar that you might be asked to leave it in terms of pi, so keep on the lookout for that, because it makes the number you have to enter in a lot easier. If I multiplied the pi through, I would have to do some rounding, and it would be an irrational number because pi itself is an irrational number. As far as the volume goes, I would do 4/3 pi times the radius, which is 4.5 cubed. That works out to be 121.5 pi, and that's in cubic centimeters. Since the pi is already there, I'm just going to write into 121.5. In the next problem, you were asked to make use of Euler's formula, which is basically, determining in any polyhedron how many edges, vertices, and faces would make sense under the given circumstance. And basically, Euler came up with this formula that said that for any polyhedron, the number of vertices minus the number of edges plus the number of faces should always equal 2. I've seen this formula expressed in different ways in different textbooks as well. So more commonly, it's usually the number of vertices plus the number of faces equals the number of edges plus 2. That's how I oftentimes see it. So keep in mind about that. But so for each one of these, you're given how many of two of these three numbers. You have to find the third one. So for A, you're told that the polyhedron has 12 edges and 8 vertices. You want to figure how many faces it has. So I'm just going to put in the numbers for what I know. I know there are 8 vertices, there are 12 edges, plus the number of faces should equal 2. So I basically have f minus 4 equaling 2, which means f would equal 6. So basically, if a polyhedron has 12 edges and 8 vertices, I would expect that it has 6 faces. For B, I'm told it has 9 faces and 14 vertices. So number of vertices is 14 minus the number of edges, which is I don't know, plus 9 faces. That should equal 2, which means that 23 minus E should equal 2. And that means that E would have to be 21. So if a polyhedron has 9 faces and 14 vertices, it would have 21 edges. And lastly, you're told that a polyhedron has 18 edges and 10 faces. So V being the number of vertices, minus 18 plus 10 should equal 2, which means that V minus 8 would equal 2, which means V would equal 10. So if a polyhedron has 18 edges and 10 faces, it would have 10 vertices. For the example that followed this, you were given a couple of figures and asked to find their volume. Now this is considered to be a prism. The prism has a trapezoid face. Boxes and cubes are also prisms as well. So some of the formulas you're seeing for this are very reminiscent of them. One of the things you have to sometimes keep straight, though, is that as you do some of these prisms, there's going to be a height of the prism, and there may be a height that you're using to calculate the area of the base. I have that here. This 24 inches is the height of the prism. When I do the calculation eventually for the volume, which is the area of the base times the height, this height right here is going to be the 24 inches eventually. As I go through this, though, I need to know the area of the base. Now, the area of the base is this trapezoid. Of course, there's one down here, too. So since the bases are trapezoids, the area of the base is going to be 1/2 the height times the sum of the two bases. This height here is the height of the trapezoid base. It's not the same height as above. So you do have to make sure you keep them straight. A lot of times students will put 24 down here because they say it's a height, but that's the height of this base, not the height of the prism. So keep them straight. Because to calculate this, I'm given that this base is 12 inches. This base is 8 inches. So I have bases of my base. So again, you're trying to keep them all straight. So the area of this base is going to be 1/2 10 times the quantity 8 plus 12. And that equals 100 square inches when all is said and done. So now going back to this formula, I have the area of the base, which is 100. I know the height's 24. And I multiply those together, I get 2,400 cubic inches. And that's what the answer is. For the next one, you're given a triangular-based pyramid. And this triangular base, it happens to be a right triangle. So to figure out the volume, I'm going to do 1/3 the base times the area of the base times the height. The height of this pyramid is this 13-foot side, because it's going from the top where the triangular faces intersect each other, and it's perpendicular to the base, which is this right triangle. It's 15 by 9 foot by whatever that would be triangle. But that is our base, which is a right triangle. Now, since it is a right triangle, again, because we've done an example in in the previous lesson, where when I do the area of this triangle, I have the two legs of this right triangle, and the legs are a base height pair. So I can let one of these be the base of that right triangle. I can let the other one be the height of that right triangle. So this 15 foot is the height of the rectangle base. It's not the height of the pyramid. I have to make sure I keep those straight. Hence the use of different colors and everything. This is the base of my right triangle base. So again, a lot of terminology, sometimes even symbols, letter symbols, might be used in a couple different areas. So when I do the area of the base, which is a triangle, it's 1/2 the base times the height. It's 1/2 9 times 15 here, which is 67.5 square feet. I know the area of the base. I know the height now. So when I do the volume calculation, it's 1/3 67.5 times 13. And when I work that out, it's 292.5 cubic feet. In the following example, you were asked to do some unit conversions, but now you're dealing with cubic units. The procedure is identical to what you did for square units, and almost identical to what you would do for basic standard units. So starting with 15.75 cubic yards, if I want to convert that to cubic feet, I'm still going to keep aware of the fact that there are 3 feet in a yard. So I'm going to start with 15.75 cubic yards. I want to convert it to feet, cubic feet eventually. So I'm going to put feet on top, yards on the bottom. There are 3 feet in 1 yard, and I'm going to cube that. And so I'm going to have cubic feet and cubic yards, which would cancel with that cubic yards. And that would give me cubic feet. So essentially what's going to happen here is I'm taking 15.75 times 3 cubed, which is 27. I end up with 425.25 cubic feet. Going from 13.7 cubic meters to cubic centimeters, I know that there's 100 centimeters in a meter. So again, I'm going to start with the cubic meters. I'm going to use the conversion of 100 centimeters for every 1 meter, but cubing that, it's going to give me the cubic meter I need in the denominator to cancel with that cubic meter, and therefore I'd be left with cubic centimeters. So as far as numbers go, I'm going to have 13.7 times 100 cubed, which is 1,000,000. And so this ends up being 13,700,000 cubic centimeters. 9.5 cubic feet into cubic inches. So I know there's 12 inches in a foot. So starting with 9.5 cubic feet, I'm going to deal with 12 inches per every foot, and cubing that's going to give me how many cubic inches I have per cubic foot, allowing me to go into cubic inches. So 9.5 times 12 cubed, which is 1,728. That gives me 16,416 cubic inches. And lastly, I have here 5 million cubic centimeters. I want to convert that into cubic meters. So very similar to this calculation here, except now I'm starting with the cubic centimeters. So the 1 meter is going to go on top, the 100 centimeters is going to go on the bottom, because when I cube that eventually, I'm going to have cubic centimeters in the denominator. This one's technically the numerator. They would cancel each other out, leaving me with cubic meters. So I'm going to take this 5 million divided by 100 cubed, which is 1 million, which gives me 5 cubic meters. In the last example, you're given that you have this baseball in a cube-shaped glass case. The diameter of the baseball and the length of each side of the cube are both 7.5 centimeters. So we know like each one of these edges here is 7.5 centimeters, and that this ball is basically touching all 6 faces of this cube. But as we can see here, the ball does not take up the entire space inside of this case. And what they're asking you to do is figure out, well, how much of the space inside of this case is unoccupied. So note that the volume of the unoccupied space is the volume of the case minus the volume of the ball. The case is 7.5 centimeters by 7.5 centimeters by 7.5 centimeters, which means that the volume of the case would be me cubing 7.5, which gives me 421.875 cubic centimeters. The ball, kind of looking at this from like, looking at one of these faces directly, the ball has a diameter of 7.5 centimeters, which means it has a radius of 3.75 centimeters. The ball is a sphere, so to find the volume of the ball, I'm going to do 4/3 pi times the radius, which is 3.75 cubed, and I would end up with 70.3125 pi cubic centimeters. I have these two values now that were in this formula. So now to find the volume of the unoccupied space, I'm going to take the 421.875 minus the 70.3125 pi, and that comes out to be about 200.98 cubic centimeters. And so when they say round to the nearest whole number, what is the volume not being occupied? To the nearest whole number, or nearest cubic centimeter, that's 201 cubic centimeters. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about it. Until next time, have a good day.